This is video 2-3. We're looking at graphing data and numerical relationships. So, in some of your labs and also some of your problems, you're going to have to look at some data and try and figure out what is the relationship between your data points. Okay. So, your data can be usually one of two things. It can be a directly proportional quantity, in which case your y values over your x values will give you a constant. In other words, as x increases, so does the y values, and they do this at a constant rate. Okay. So if you start plotting your values, you'd find out that your y values are equal to x values times a constant k, where k is the slope of your graph. Okay. And you should basically end up with a straight line. So let's say we made a graph and someone went and gathered some data, or you gathered data, and you started noticing that your x points were here and your y values were here, and they started to increase at somewhat a steady rate. Okay. Now notice, because depending where your data came from, if it's an experimental value, you may or may not end up with the points exactly in a straight line. Okay. Now what you do not do is go from here to here to here to here to here to here to here and do a connect the dot thing. Okay. What you basically want to do is figure out what is the best pattern, the general trend that you see. So what you draw instead would be something like a best fit line. Okay. Trying to intercept a line that should be intercepting the most points. Okay. Your data could also be inversely proportional. In other words, as one value increased, another value would decrease. And in this case, what happens is your x and y values, when you multiply them together, should give you a constant. So it's a product that gives you the constant. Okay. And y is equal to some constant k divided by x. And what you should end up with in your graph is the shape of a hyperbola. Okay, now what's a hyperbola look like? Well, graph your data points. When your x is small, your y should be relatively high. As x increases, y will decrease. Okay, but it's not at a nice linear rate. It starts decreasing at basically an inverse rate. Okay, so your data points would look something like that. And in this case, what you want to try and do is draw a nice smooth curve. Okay, and again, put in a best fit curve, the best that you can. Okay, now, when you graph your data, okay, often you have to graph data that's measured, and in experimental sciences, there's two types of variables that you can have. Okay, the independent variable. This is the one that you determine, you manipulate, you vary. So let's say you're going to measure the temperature of a solution versus the period of time. Okay, so the thing that you'd manipulate would be the time, and the dependent variable would be the thing that changes. So the temperature would be the thing that would be changing over the period of time. Okay, now, where do you put these things on your graph? Okay, the x-axis is where the independent variable goes. So if we try to figure what is the function of temperature versus time, the temperature would, or the time would be going on the x-axis. Okay, the dependent would have been the temperature, and this is going to go on the y-axis. Okay. Whenever you make a graph, it is always the dependent variable versus the independent variable. And the first name is always the y value, and the second name is always the x value. So this is the title of your graph, whatever the dependent is versus whatever the x is, the independent. So let's say we wanted to make a graph or do a little experiment where we change the time and we figured out what happened to the temperature. This is actually going to be a graph of temperature versus time. Okay, now this has to go on our y-axis, this goes on our x-axis. So time will go on the bottom, again with our units that we want, and on our x-axis we put in our temperature. Okay, so let's say over a period of time we notice that the temperature started out down here, and over our next unit of time, temperature went up. Okay. Next unit of time, let's say it went to here. then it went to here, then it went to here, then it did this, and this, and this, and this, and then it started going up, and up, and up, but it did something else like this. Okay, so again, do not do a connected dot thing. Okay, you may notice that some of these points are a little bit off, but looks like for this part at least, it's kind of a straight line, straight trend line. Here, okay, do not keep extending it. It looks like there's a definite constant temperature. So draw this in as basically a nice flat line. Then again, it looks like here maybe you got a couple points that are a little bit off, but draw in. Looks like a pretty straight line like that. So it does not have to be all one continuous line, but whenever you see trends, draw in the best fit line that you can. So here's your review question. Okay, suppose a student does an experiment with multiple trials, and she changes the concentration of a reactant and measures the amount of heat that's given off by the reaction. Okay, so she collects her data. Which variable should go on the x-axis? Is it temperature, heat, time, reactant concentration, or the trial number?